हाय शुभम सर.
हॅलो. हा मॅडम बोला.
हा, नाही येतील मुलं ऍक्च्युली. ते सरांबरोबर मुलांची होती तर रंगीत तालीम चालू आहे आणि त्या सरांनी कधी गुगल मीट वापरलं नाहीये. तो
ओके.
ते कारण मुलं म्हणली मग शुभम सरच लागतील आम्हाला 3:30 वाजता, म्हणून मी ऍडमिट करायला म्हणजे सरांना. तर ते म्हणलं
ठीक
नाही
आहे.
मग तुम्ही
मी
तुमची.
आहे
हा
अदर देन पीव्हीजी ला ऍडमिट करेन मी, काही इश्यू नाहीये.
हा
बट हे
ओके.
5 पर्यंत उरकेल ना?
सी तसं काही फरक नाही पडत. एकदा शेवटचा माणूस गेला की रेकॉर्डिंग आपोआप तुमच्या ह्याच्यात जातं. तुम्हीच रेकॉर्डिंग बंद करायला पाहिजे असं काही कंपल्सरी नाहीये.
नाही, तो विषय नाहीये.
हा,
कारण मला लॅपटॉप ऍक्च्युली पुढे द्यायचा आहे, मला भावाला. त्याची
तेच सांगते
मीटिंग
ना.
आहे.
तुम्ही
हा.
मग इथनं तुम्ही आता मोबाईल वरनं पण एक लॉग इन करून ठेवा मग
हम्म.
मीटिंगला, बर का?
बरं, मी आता जर मोबाईल मधून केलं आणि मी लॅपटॉप मधून बाहेर पडलं तर रेकॉर्ड चालू राहील का?
हो हो हो, कारण ऍडमिन सेम आहे ना. पण आधी शुभम मोबाईल वरनं ऍड व्हा आणि मग तिथनं
एक
बाहेर
मिनिट.
पडा लॅपटॉप मधनं.
एकच मिनिट. तसं जर झालं ना तर बेटर ऑप्शन आहे हा.
हो.
कारण माझं सगळंच हे होईल. ओके, मी
येस.
झालोय जॉईन आता.
हा, आता तुम्ही बंद करा लॅपटॉप मधनं, आउट व्हा.
हॅलो.
राईट. हा, सो ऍडमिन
हा,
सेम
रेकॉर्डिंग चालू आहे.
चालू झालंय. करेक्ट. पण
ठीक
आता
आहे.
तुम्हाला परत लॅपटॉप वरनच करावं लागेल, कारण मोबाईल वरनं रेकॉर्ड सुरू होत नाही. त्यामुळे परत
हो हो.
तुम्हाला.
म्हणजे आता आपलं काम झालंय. आता मी जरी हा लॅपटॉप त्याला दिला ना
हो,
तरी काय हरकत नाहीये.
करेक्ट. आता हे पण सगळं रेकॉर्ड होतोय, सो वी शुड स्टॉप
हो.
रेकॉर्डिंग दिस.
आता राहू देत ना रेकॉर्डिंग चालूच का नको?
नको, आता बंद करा. सर आले की मग विल जॉईन.
त्याला परत आता लॉग इन करावं लागेल.
एक ठेवा ना 4:15 पर्यंत तो ऑन.
ठीक आहे.
हा, हितेश. हा, येस अक्षय. वेअर इज एव्हरीवन?
Hello, ma'am. Ma'am,
हा,
actually, me and Kogat are having a the sir is not known to the technology right now, so we are having an other meeting, like a dumb meeting, mock
येस, बट
meeting
यू
with
हॅव टू
him.
फिनिश
So
इट
like
नाव.
to tell him that he will be. Yes, sir, we are done. Just 2 minutes. He will be joining this meeting right now.
ओके, बट बिफोर दॅट वी
He's
नीड
in
टू.
actually Omkar is instructing sir to join this meeting. He is having a trouble with.
यू प्लीज
Yes,
आस्क
ma'am. I
अदर्स
will
टू.
ask everyone to join.
येस येस.
Yes, ma'am. Just a minute. Yeah.
हितेश, प्लीज इन्फॉर्म युअर क्लासमेट्स
येस
टू
मॅम.
जॉइन मीटिंग.
हा हो मॅम, मी
ओके.
केला आता मेसेज.
योगेश.
Yes, sir.
योगेश,
Yes, sir.
तू पण सांग फायनल इयरच्या लास्ट इयरच्या स्टुडंट्सला अनऑफिशियल ग्रुप वरती पटकन जॉईन करा
हो सर
म्हणून.
सांग हो सर सांगतो.
हम्म.
Hello.
Hello,
You
sir.
can hear me?
Yes, sir. Yes, sir. We'll start in 5 minutes. We'll wait for students to join.
Yeah. Good afternoon, sir. Narendra, sir.
Yes. Good
Hi.
afternoon.
Good
Hi, how
afternoon.
are you?
I'm good. How are you?
Nice to meet.
Same here. Same here. Virtually का हुई ना भेट झाली
Yes,
पाहिजे
yes,
असं
that's correct.
व्हायचं. Yes. Yes. I will just start in 5 minutes. I hope तुम्ही Google Meet शी थोडं familiar झाला
Okay, no,
असाल
no problem. No,
आतापर्यंत.
no problem.
Yeah. We'll just wait for 5 minutes and then we'll
Sure,
start.
sure. No problem.
Because the faculty member left from the college at 3:30, so they are still reaching their house. So they said, you start, we'll join because they have the full-time college. They have to go full-time there.
Okay.
Yeah. Though, I mean, students are not going. Only the full-time faculty is
So how
attending
you
the
are
college.
operating now during this time? There are no student directly coming to college, or
No, it is not allowed only from the
it is not
university
allowed?
only. Yeah,
It is not
yeah.
yet started. It is not.
Yeah. No, it is not started. No.
So everything is online. You are having
Yes.
Google classes?
Yes.
Okay.
Google Classroom we have for each subject, and like everything is online. So
Very good.
they are also learning new things along
Yes.
with school.
This is I am also first time attending this type of. I generally do Zoom actually. Google Meet.
Right.
It is that. But
Actually, we
Google is very
use
good
this.
for educational, I think. It is,
Yes, Google is quite handy. You can say
actually.
like provides a lot of other like Google Quiz and Google Documents and
That
so
is
it
mainly
becomes,
even in schools. Schools also it is very
right,
common. It is very common.
right. So it becomes easier for students to share everything,
Yes,
whatever we
that's
want to ask them to share.
but a lot of organization require from your side.
Yes,
You have to everything present in this form now, new form.
new form. That's true.
So
I
the
don't know. Yeah, because it has been, I mean, we are not sure when the college will open or when the university will give the permission to, start the college. But slowly we'll start taking the practicals as well online. Because otherwise, if the exams is online,
how
then
you will do practical online?
so that's why the faculty can go to the college and come online from the college and show the students like this is the instrument.
But they will not do. They will not do that.
No, they won't. But we are fine. Like we are trying to, get the basically practical is what you are taking the reading most of the time. So if the teacher can tell you the demonstration how to take a reading, and if the readings are given to students, then they can do the calculation and analyze the result. Like okay, असं आलंय म्हणजे काय असेल किंवा ह्याचा काय अर्थ असेल. I think students are also getting used to it of online teaching current त्यांचं पण
Practical means unless and until you do yourself,
you
it is
do it.
very
That is
difficult.
unless we try some stimulators, if we can get some stimulators for them. आता सच ऑन मशीन असं काही आता त्यांना सिलेबस मध्ये नाहीये कलर एक सोडला विषय तर म्हणजे किंवा ग्रेव्हियर वगैरे विषय आहेत तर त्याची प्रॅक्टिकल्स पण थोडी अवघड आहेत ऑनलाईन घेणं पण ते वी आर ट्राईंग कुठे ना कुठेतरी काहीतरी होईल.
But I think after December, January, it will be getting normal.
या पण असं आहे की आता परीक्षा तर घ्यायचीच आहे सेमिस्टरची त्यांची सेमिस्टर वाईज पॅटर्न असतो त्यामुळे आता परीक्षा कधी आणि कशी घ्यायची ते लची कसं काय होतंय.
Should we start, ma'am, or should we wait for a few minutes?
Yeah, we'll wait for Joshi madam. No, she's coming in 2 minutes. Yeah, she's just reaching the house. That's what she told me when I called her.
Okay, ma'am.
Yeah. Meanwhile, you can share your screen and show the first PPT if you want.
Yeah.
Yeah, good. Okay. I think we need some more T students. It is hardly 10-15 of T students. Where is the rest of the class? T printing. All right. I think madam is here or no? Okay. I think she is unable to join. So one second. Yeah. Hi, Joshi madam. Shall we start?
Yes. Hi. Good afternoon, everybody. Yes, Shrikala ma'am. Let's
Yeah.
begin.
Okay. Yeah. So Omkar.
Yes, ma'am, I'll start.
Yeah.
First of all, good evening, everyone. I, Omkar Okate, am pleased to tell you that the students of TV printing have brought up an event for the week called the Color Week. As the name suggests, the Color Week will be based on a single topic, color. In this week, we'll be having webinars for webinars by 6 different industry experts for 6 days on 6 different topics like fundamentals of color science, transformation of color, difference between CMS and process standardization, instruments used in color management, brand identity, and importance of color, dot gain versus G7. I request all the students to attend as many webinars as possible because these industry experts have tremendous knowledge and experience in the field of color science and management. After each session, we will be having a small quiz related to webinar and scores of each students will be recorded. And at the end of the week, scores of each students will be added and the top 5 students will be considered as winners. The criteria for the quiz is the fastest to answer correct questions. So before starting with the session, I would request our Professor Padmaja Joshi ma'am to inaugurate the Color Week by sharing a word with us. Over to you, ma'am.
Yes. Yeah. Good evening, all. Shrikala ma'am has sir joined Gangakhedkar sir.
Yes, I'm there.
Yes, sir. Namaskar, sir.
Namaskar, namaskar. Nice meeting you.
Uh, so yes, nice, sir. I can't see your video though. Maybe 1 second. Okay. Uh, so आपण start करूया sir session. Okay with you?
Yes.
Yes. Okay. So I will just inaugurate the session. Since Mahajan ma'am is busy with some other schedule,
Hmm.
we have got our final year exams scheduled for tomorrow. So I'm just on her behalf. I would like to inaugurate the session. So as Omkar rightly introduced or shared with us that color is the most important part of the printing, and then understanding about the color, and for understanding about the color, having a speaker, having a well learned speaker like Dr. Gangakhedkar is the most right thing. So we are really lucky to have. We have heard students, though you may not be aware, but we have heard sir before also. And then he is a very senior person. I'm sure when he will be introduced to you all formally, you will get to know through that, and through his speech also we will understand it. And as we are already aware that in this full week we will have the full gamut of the color explored as such. So color is applicable applications of the color in advertising, its scientific or technical way of understanding, and every other aspect will be uncovered. So it is great to learn and see that PE printing students have come ahead and they are organizing such a wonderful color week. The name of the event is also very creative. So all the best, my best wishes to all the organizer team and all the students. Every one of us, we look forward to have a great interaction with all the speakers, and I'm sure it will be a great takeaway for all of us attending the session. So now I declare that the session is inaugurated, and over to you, Omkar, for the further proceedings.
Thank you,
Thank
ma'am,
you.
for your wonderful words. Now, my friend Akshay Ingre will give a brief information about Mr. Gangakhedkar sir. And over to you, Akshay.
Yes, thank you, Omkar. So it's my immense pleasure to introduce about Dr. Narendra Gangakhedkar. He's the expert in the color science and its application in computer color matching for various color industries like textile, paint, ink, pigment, and many more. He's the color technology consultant and offers a solution to the color problem. He completed his PhD from University Department of Chemical Technology (UDCT) and has a diploma in radiological physics from a very prestigious institute, Bhabha Atomic Research Center, Mumbai. And he completed his advanced course in color science and technology from the Institute Resler Institute, Troy, New York, USA. He has more than 40 years of experience in the color technology related business. He's just not an experienced person. He's also the international expert in CCM techniques in paint, plastic, inks, and textiles. He has developed a computer color matching software for the paint application and is his founding member and general secretary of the Color Group India. For his exceptional work in the industry, he is awarded by many national and international awards. Some of them are Exceptional Performance Award and $1 Million Club Award by Data Color International, the 21st Century Millennium Award, and the very prestigious Rajiv Gandhi Shiromani Award, and many more such awards. Dr. Narendra Gangakhedkar is also a renowned author and has written 4 books on color. His latest book is Chromatic Notes, which has launched in March 2020. Chromatic Notes is a handy little reference for color management and technology and has a comprehensive information on various aspects of modern color science. Friends, it's a pleasure to have the opportunity to be the part of session and have such a great and experienced speaker with us. Thank you, Dr. Narendra, for being in the session. Now I would like to Omkar to take over from here.
Thank you, Akshay. A very nice speech, and thank you for giving us a brief information about Dr. Gangakhedkar sir. So now I'll hand over the mic to Gangakhedkar sir.
Thank you. Thank you, Akshay. It was a very, very nice introduction. First thing is, I would like to thank your institute. It is a very first chance. First thing is, I must thank Srikala Sane Kanade. She actually contacted me very recently and she invited me for this seminar. And Omkar and Akshay both coordinated with me actually. It is very nice to get introduced with your institute. Actually, I am associated with your institute for quite a long time. I have earlier visited, I think it is more than 10 years old now. 10 years. In the past, I have attended, I have given lectures for 3 days, continuous 3 days in your institute. So I'm very familiar with your institute and the students who are really working in printing technology, and they are doing a lot of good work, as well as I know about your staff members, and they are the best in printing technology. Now,
Thank you, sir.
actually, I am going to talk on fundamentals of color science. Not much about the printing aspect of that one. It is a general aspect about understanding the color science. And this is applicable to all industrial fields. It is applicable in paints, plastics, textile, and inks actually. And you are also not doing one type of ink, you are also in various types of ink and ink technology. So there are different applications and different methods in your ink technology. So that is a very vast subject, and I think you have very good speakers. They are going to talk about that. I am mainly going to talk to you about what is color. Now, the very first thing which can you hear me all? Hello?
Yes,
No problem?
no problem.
Okay.
Yes, sir,
Now,
we can hear you. We can hear you, sir.
see, artist manipulates color, scientists analyze color, and industrialists exploit color. Now, we technologists are in between. We are helping industrialists. We are working for industrialists and other things. So we are exploiting the color, and we are not really full scientists. We have to understand scientific methods, and then we have to use the technology for exploiting the actual application in the industry actually. That is one of the very important aspect of that one. So fundamentals of color science, when I am talking, whether color exists, the very first question comes to my mind that color doesn't exist. When I will say this, that color doesn't exist, you will say, yes, how color can exist? Color will exist if there is an eye, and if you are seeing the color, then you will say, if there is no eye, there is no color. If there is an object which is not actually painted with the help of textile material, pigments and dye stuff, then color doesn't exist. And if there is no light falling on that, just for example, you think that there is no sun and only darkness is there. So what color you will see of the object? So color doesn't exist if three things are there. If there is no light, there is no color. If there is no eye, there is no color. And if there is no object which we call that it is colored, then there is no color. So color to me actually doesn't exist. If color doesn't exist, then how we are talking about color science? If we are talking about color science, then we have to really understand what is behind it. And unless and until I understand the basics of color science, I will not be in a position to quantify color in terms of number. And we say that color is to be digital color matching. You are talking about digital color matching in your ink technology. Now, how you can talk of a digital color matching when the color doesn't exist? You have to first understand that color is existing, you are measuring, and now from analog instruments you are converting it to digits, and from the digits you are seeing that yes, this particular color is having this XYZ or LAB, and if XYZ of A is equal to XYZ of B, then the color is matched. That is what you are talking as a scientist or as a technologist. When you are using I1 Pro as an instrument and you are measuring the color and you are saying these are the RGB values. If I match RGB is equal to RGB, then the color is matched. But how these RGB are coming, how the scientists are analyzing this color and measuring this color in this way, that is exactly what I am going to talk. So I am going to talk about the color measurement, quality control aspect of that. Now, how we go for the formulation, and then how you go for a production batch correction. And there, in the later part of my talk, I will be showing you something which is more related to your subject, that is ink master and also the digital printing. So in these two cases, if I get some time, I will certainly show you how we use in computer color matching the ink application. So let me start. The next slide, please. Now, as exactly I told you that color matters. That is very important. Color matters for artists, color matters for industrialists, color matters for scientists. Can we measure the color? If we can measure the color, then measurement matters. That is also very important. Color measurement is color management. Now, most of the thing you will be seeing only the slides, and I am going to talk just few seconds on the slide. Now you have to only think about that, and then you open your books and then find out the answers for that. I'm not going to give you answers. I'm just going to increase your interest into the subject, and you have to exactly find out what is there in your books. So the color measurement is color management. When I'm talking about color management, you have to first understand how color is to be measured. Next slide, please. Now, we talk of computer color matching and CCM system, etc. That is much later part. But before that, we have to really, I am not going to talk anything about computer because you know about that. I'm not going to talk about color. I'm not going to talk about pigments and dyes. So that is something related to color. And I'm not going to, today, I'm going to talk about matching, that somebody has given me this particular color and he's asking me, I want to get exactly the same color, then how that color is to be matched. Then for that, we use the systems like CCM system, where you are having color measuring instruments like I1 Pro, and you are having nowadays computers, and even with the help of mobile computing, you can also do the formulation and correction, etc. So this is exactly what we are going to do. Next slide, please. Now, I'm just going to ask you a few questions. I'm just raise some questions in your mind. Let us understand what is color. And we are only going to talk about color talk. Next one. Next slide, please. Secondly, we will try to understand how to compute color, how to digitalize color, how to measure the color, what is the colorimetry, or what is the spectrophotometry. So in short, we are only measuring the color, and that measurement matters. That is exactly what I am going to talk. And then you have to also think of that, how we are really going to use this measurement and how we are going to use this digitalization. Next slide, please. Thirdly, let us know why color do not match. This is the main concern. When you are in industry, you are having these problems. Why color do not match? And that is a problem for everybody. If he is a painter, if he is a textile dyer, some lady goes to the shop and says that this is blouse piece and I want to get exact match with my sari. This is the common thing which you see that, and they don't match. Then why they don't match? Whether the sari is a cotton or a polyester or acrylic or nylon, and whether the blouse piece is cotton or she wants only cotton because she cannot wear the nylon blouse piece, etc. So in that case, how you will match those colors? That is a simple problem. When you go to the shop, you will see that color do not match, and she will be just throwing 4 or 5 pieces. She said, no, none of this color is getting matched. That is very natural, and we don't know. And then sometimes what happened after matching the color, she goes outside the shop and she sees whether it is matched or not. Now, why she goes outside the shop? Mainly because colors match in the shop because the shopkeeper is keeping some light sources, and under that light sources, the two pieces are matching. As soon as she goes outside, the daylight is different than what you see inside the shop, and naturally color do not match outside. So this is very, very important. That means the illuminant light source is very important to get a match. And we say that why she is refusing this one. Because she is more intelligent. She knows that color do not match if there are different lighting conditions. This simple thing we do not understand when we work in industry. Next slide, please. Fourthly, let us know how to use colorimetry for color matching. This is exactly, so whether our instruments and computers and other things can really give us the color, whether it is match in daylight or artificial light or cool white fluorescence or TL84. So whatever light source I am having, it should match in that. That is exactly what colorimetry or computer color matching or spectrophotometry should give the answer to our questions. Next slide, please. Fifthly, how computer software was developed and used for color matching. First thing is, color itself is a sensation. And if it is a sensation, how it is quantified. Next, second is, when it is quantified, then as I have already told you, the triplet is very important. Light source is very important. Pigments and dyes are also very important. And the third thing is, your eye is very important. So can we simulate our conditions, what our eye is? Who is a standard observer? Whether I am a standard observer or somebody is a standard observer. So that is very important in this case. So the color matching plays very important role unless and until our software, our technology takes care of all this. Next slide, please. Next. Sixthly, the recent advantages. There are many advantages. Instruments are changed. Every 3 years, 4 years, spectrophotometers and colorimeters are changing. Software is changing because operating systems are changing, computers are changing. When I started, it was a big IBM or ICL computer. Operating systems were totally different. I was using punch card and all other things, etc. Now everything is there when you are using. Nowadays, even mobile computing is so fast that I don't have to go back 30 years back. What was the computer system? Then what was the software? There are so many programs that time. I used to write program in Fortran 4. Now you don't have to write the program. You are having certain packages. You mix those packages and you can develop your own software. So these are the things which are taking place. So 4, 5 generations, color matching software has changed. 4, 5 generations, spectrophotometers have changed. 4, 5 generations, the color theory has also changed. So we have to, because color difference equation, how many equations are there? There are 25, 30 color difference equations are there. Which color difference equation I should use? If I am in printing, what is most ideal? If I am in textile, what is most ideal? So these color difference equations, and that means it is all related to the software. That is also to be understood. So these are the things which you should think, and then you will understand exactly how complicated it is and how this particular technology is developed during last 30, 40 years. Next slide, please. Understanding cost of coloration. That is most important. In industry, what is important? If I am using all these technology, naturally, it should finally give me the saving. If the cost saving is not there, if my dyes and pigments are not saved, if my ink is not saved, then what is the use of that? If I am getting a formulation at very high cost because you are doing by trial and error method and you have selected certain dyes and pigments which are again not matching in daylight, artificial light, cool white fluorescence or whatever conditions which I want, then naturally what is the cost of coloration? This cost of coloration is the most important thing, and that is why CCM technology is becoming very popular, because it is finally giving you the least cost and the best match. So these are the two things which we want. We want a best quality match and we want the least cost. And if that is to be achieved, we have to use this modern technology. Next slide, please. Right first time matching, that is another thing. Just these are the pigments, these are the inks which are there. Mix those 3 inks and this is my match which you have to give me, and you have to give me match in 1 hour, in half an hour, in 3 hours, whatever is there. And as soon as I mix them in production, not in the laboratory. I can do it in lab, but when I go to the production, there are so many process variables. And if I don't get right first time matching in production, the CCM system will not give you the results which you are looking for. So my aim is right first time matching, whether it is in textile, whether it is in paint, whether it is in ink. In ink also, when you first draw and you get a picture of that one, and if that is not coming in first time, oh, this is lighter, this is darker, this is coming too much yellow, too much red, no, this is not acceptable, then you go on mixing. That is not allowed in that case. So right first time matching is our aim, and now 85%, 90% people are getting right first time. That is the technology which has developed over the year, but still there are problems because there are different pigments coming up, different technology coming up, different processing coming up, and all those things are creating a lot of problems. Next slide, please. Scientists analyze color, as I have briefly told you. Scientists analyze color, artists manipulate color, and industrialists exploit color. Next slide, please. No light, no color. This is exactly what I told. The light is falling on the apple, and I am seeing this one. If there is no light falling, then naturally I will see the apple black. Next slide, please. What is color? So everybody goes back to the Newton. Newton was a very smart scientist and guy. He just had a prism. He was playing with the prism. Light was passing through the prism, and his wall was illuminated with Vibjor color. And he said that light is nothing, but it can be segregated. It can be split into 8 components, and we got Vibjor. We have 7 components, and we got Vibjor. So what is color? So for this, you say the light is not white light, but it is consisting of 7 light. Then you talk of wavelength 400 to 700 nanometer. Then what is the wavelength below 400 and what is the wavelength above 700? Whether they are concerned with the color or not, those things are very important, which you have to understand. Now again in the light, you will say when the addition of light, when you are adding 3 lights, red, green and blue, when these 3 lights are added, you get the mixture color. When you are, but as far as pigments and dyes are concerned, you are not adding red, green, blue. You are adding cyan, yellow and magenta. So the primaries are changed. Now these primaries, why they are changed? Because your pigments and dyes cannot give those pure green, pure red and pure yellow. So addition of light is different than addition of pigment and dyes. So your primaries are cyan, yellow and magenta. And those who are playing with light, when I am talking about the matching of colors on the TV screens, then naturally it is a mixture of red, green and blue. So finally we have to get exact colors by mixing red, green and blue on the TV color. That is not the case when I am matching a particular textile sample or a plastic sample or an ink sample. Next slide, please. Now this is the Vibjor color, which you know we are a very small portion of the spectrum, 400 nanometer to 700 nano, or maybe some 380 nanometer to 680 nanometer. These are the wavelengths which are very important. So if we quantify color in terms of reflectance value, then we will be very important for this particular small area of the spectrum. Next slide, please. Now this is what I have already told you, that primary colors are there, red, green, blue, but that is for addition of light. And secondary colors are cyan, yellow and magenta. That is for mixture color. So when you are mixing pigments and dyes, they are very important in that. Next slide, please. Now this is exactly, everybody knows, I don't have to even explain you. When you mix red and green light, you get yellow. Similarly, if you are mixing the cyan and blue, you get the mixture colors of that one. This is exactly what is shown. You can see the books and you will get an idea about that. Next slide, please. Now, this also everybody knows, but I'm just basically telling you the same thing, primary colors and secondary color. We call not primary and secondary, we call additive color and subtractive color. So when you are adding light color, then it is called additive color. And when you are using pigment and dyes, we call that primaries, and that is called subtractive colors. They are used in ink. Next. Why colors don't match? This is exactly the problem is there. And with the help of instrument, I can say, or with the help of digitalization, I can say that colors can match 100%, or they will be perfect match. Now, why color do not match? There are so many questions. There are different questions in paint industry, textile industry, and also in your. Next slide, please. Now, this is a very simple example. Young boy and young girl looking at an apple, and girl is saying, yes, it is burning red, and boy is saying it is red. Two old people are there, one old people and one young man is there. Young man says it is bright red, and old man says it is crimson red. So the variation, color interpretation goes on changing, your mind is changing. So color is not only related with your eye. Your light is falling on your object. Object is reflecting the light that is received by your eye. Eye is now converting that signal into chemical energy, and that is gone to the brain, and brain is interpreting that one, and because of that you are giving your interpretation. So the physiology and psychology plays very important role. So physiology and psychology of interpretation of color is related to the age. Young boy or young girl, girls are talking different colors, and old people are also talking different. So you have to understand color physics, color physiology, color chemistry, color psychology, color physiology. Then you have to understand color instrumentation, and then you have to understand the digitalization, and then you have to understand computer hardware, then you have to understand computer software, and all these integration gives you modern technology, modern color technology. That is exactly what I am going to talk. Next slide, please. Next. Now this is very simple. These two boys are going to the school. When they are outside, they say that, oh, both the bags are exactly same. Mine and your bag is very good. But say they are same because under the daylight, under the sunlight, they are matched. As soon as they go to the classroom and lighting conditions are different, and one is looking redder and other is looking gray. Now they are fighting. No, your bag is not very good because it is something not a good quality, and that is why they are started fighting. So the color is changed and the lighting is changed. That is what a very important aspect. And this slide is very important to understand that if the lighting conditions are changed, color is changed. Next slide, please. Next slide. Now this is another example. Now you are seeing the two pieces of textile material. In artificial light, one is looking lighter, another is looking darker. And in daylight, it is looking perfectly matched. So this is what exactly why the lady is going outside to check whether the blouse piece is exactly matching with the sari. And that is why this is called a metamerism. Metamerism is a very, very important concept in color. You have to exactly understand that under different lighting conditions, it is not only two lighting conditions, artificial light, daylight, cool white fluorescent, TL84, and n number of light sources are there, illuminants are there. If n number of illuminants, I have to go on matching depending upon the requirement of the industry, then in that case it will be very difficult, and then I have to select proper pigments and dyes for getting the matching in that particular lighting condition. So that is very important. So unless and until you don't understand the mechanism, understand the importance of metamerism, you will not be able to satisfy the customers who are really looking for. Next slide, please. Now this is another example, same thing which I said, two people are looking at. One fellow is saying that it is a red apple, another is saying that it is not red apple. Now mainly because color blindness means physiology of the eye is very important. Actually, we understand very little about color physiology. We have to go to the doctor and physician, and we have to really ask, and he interprets, and he may not be knowing what you are talking of metamerism and all other things, etc. So the physiology and psychology, these are the two most important aspects which are not really related to us because we are scientists and technology. Then we face problem if we are colorblind. So that is what very important. Color impressions are different for two different observers. Next slide, please. Now, color is cheating us. Color is affecting colors. You can see that with the black background, there are a number of colors which I have drawn, and there are same colors I have drawn on the white background. Now you can see when they are on the black background, they are looking bright colors. And when they are on the white background, they are looking dull colors. So this is color affects colors. So this goes to those people who are artists. They create all those things and they need all that. And but they don't understand that whatever color I am giving him and he is using, it is the same yellow, but it is creating an effect which is because of the different background. And then they complain that the color which you have given is not correct. So that is exactly why artists are facing the problem in there. You can see that green behind the yellow background and green behind the blue background. When the green is behind the blue background, you see that it is yellowish. And the one with yellow background, it is looking bluish. So that means it is theory of opponent color. So that means physiology, psychology of eye play a very important role, and we are deceived because of that. So color really doesn't exist. Whether we call it greenish or bluish, it may be totally different. But here you can see that how color affects color. Next slide, please. This is the slide which I have already shown you, but you can see much better effect here. You can see that with the blue background, you can see yellow color. But actually it is not. If you measure the reflectors on the blue background and the yellow background, reflectors values will be same. There will be zero. So from digital point of view, there is a zero reflectance difference or zero XYZ difference, zero LEB difference. So then I can say that, okay, it is fine. It is only your backgrounds are cheating you, but the color is not cheating in this case. Next slide. Color is within us. That is what exactly I told you. And now we have to design a spectrophotometer or an instrument which is just like our eye. Whether can we design an instrument or a video or a scanner or a camera? Now, these are the things which you are using. So as far as you are concerned, in your printing, you are concerned with scanner. Those who are doing on computers, they are doing with video, and those who are reproducing the color and printing, then it is also related to the camera and scanner. So these instruments are equally important. Unless and until these instruments, including spectrophotometer, are not equivalent or not understanding the physiology, psychology, and triplet which I am talking about, unless and until they are not designed according to this, you will not able to get color matching perfectly. Next slide, please. Now, you talk of CMYK. In the ink industry, you are only talking of CMYK. CMY, cyan, magenta, yellow, and K is a black. You use black. You don't use white. But there are certain people, there are inks which are with titanium dioxide. So that is different thing. But what is your color gamut? You must have heard the word color gamut. What is your color space? The total color space which you can see is the outer one, and the CMYK which you are using is the inner one. So how much area of the color space is to be exposed? You are still not in a position to produce those colors outside your CMYK gamut. That means you have to have better and better cyan, magenta, and yellow. Unless and until you achieve that, you will not get the CMYK. You will not get the hexagon gamut, which is very important. So that means there is a limitation. When I go for paint industry or when I go for textile industry, I'm having very, very limited color gamut. When I go to plastic industry, my color gamut is very, very small as compared to what you are having in ink. So why I am showing you this slide is that what are the things which are possible. So you talk of CMYK, and if you are not in a position to produce a color which is outside this gamut, how much limitations you are having in your technology. That is exactly what I wanted to tell you. Next slide, please. Oh, this is exactly what I am touching, additive color of mixing. Different applications have different methods of color matching, additive and subtractive mixing. And there is a challenge for everyone, whether it is a paint industry or whether it is a ink industry. There are big challenges, and we have to come out over that because we are not in a position to produce those pigments and dyes which will cover my color gamut, which will cover the wider color gamut. Next slide, please. Why color don't match, which I have already explained to you. Color affects color. Identical colors can be metameric pair. Color affects color. The human eye is different from a scanner or a camera. Human eye is different from scanner or camera. This is very important to your application. Different devices have different color gamuts, and different devices use different color models. So you are not using the same model which I am using in textile for determining the delta E color difference for expressing. I say I am using Scilab 1976 or I am using CMC. You will say, no, I don't want, I want D 2000 or whatever is there. So different devices are using different color models. This is very important when we talk about color matching. Next slide, please. Color is light, color is pigment, color is sensation, color is information, color is mystery. If color is mystery, still it is a challenge for us, and only this is the out of 5 sensation. This is the only sensation which is quantified, which is computerized, which is digitalized. All other 5 sensations, all other 4 sensations are not computerized, are not digitalized. Thank you. Next slide, please. Now, as I told you, there are different light sources, then there are different objects, then the eye is very important and the brain is very important. So it is color physics, color chemistry, color physiology, and color psychology. Next slide, please. So visual judgment of color is based on physical, physiological, and psychological. Unless and until you understand all these aspects, and all these people work together. Physicists, physical chemists, physiologists, psychologists, printers, painters, textile chemists, all they work together, and that is how color science is developed, and that is why it is very wide subject. It is an interdisciplinary subject, and one has to really look into all areas, then only one can understand that. Next slide, please. Now everybody talks, I will tell you, Munsell was the first one. He said, no, I cannot. That time the color measurement was not talked about. He said that I will organize color in such a way that everybody will talk about the same color. So he says that I will organize all colors with hue. So the hue is nothing but red, green, blue, yellow, and between yellow and blue, then there is a blue, green, and again between that there is another green. So he defined the hues. He defined that every color is having white content and black content. So every color is having zero as black, and he is having 100 as white. So he has given the number 0 to 10 or 0 to 100, and he has also given the for hue 5.5 red. 5 red is a hue which I have selected. For 5 red hue, there is a value which is 4, but again it gets saturated. After certain thing, it is 1%, 2%, 3%, 4%, and after that color doesn't really develop further. So that is called saturation. So that he called as a chroma. So the hue, value, and chroma, these are the scientific definition when there was no color measurement possible. And every color can be, now he developed all those things, and thousands of colors were actually collected by him, and he made a Munsell color atlas. And anybody who was interested in specifying color, Munsell color system is specification of color. He said that 1.5 R, 6.28, and chroma C is equal to 7.39. So in that book, you will see a chip. That chip is the exact color which he is talking about. So that is how Munsell color system is the most ideal visual color system which can really tell you, and you can describe or specify color with the help of Munsell color system. Later on, other 2 color systems were developed, which you may be knowing. Next slide, please. The Munsell color tree, if you organize all Munsell colors in this particular fashion, you can say that these colors are organized in such way. So you will be having the saturation. You can say blue gets saturated much earlier than the orange or the yellow. Yellow is getting saturated much higher. You can see the chroma value of the yellow is very high. And amount of lightness and darkness is the vertical line. And you can see that amount of lightness and darkness decide the amount of black content and the white content into that. So the hue value chroma is a 3-dimensional color system, which is a real specification of color system. And now still it is standard and international standard. Next slide, please. Now I can define a color in terms of hue value chroma. 5/2 is my hue, value is 5 and chroma is 10. Then I will go to the color measurement. I have not come about. Then I will talk about value. X is 29, Y is equal to 19, Z is equal to 12. Then I will come to LAB color scale, and then L is 51, A is equal to 42, and B is equal to 22. Then I talk about RGB values, because in case of your ink industry, you talk of RGB, you don't talk XYZ and LAB. So the RGB, R is equal to 194, G is equal to 90, and B is equal to 82, and then you talk of gamma value, that is 2.2. Then CMYK, those who are mixing colors, which are the secondary colors, then in that case C is equal to 20, M is equal to 60, Y is equal to 61, and K. So now I have practically given you that you can talk of color in terms of Munsell value, you can talk of CIE value, you can talk of N Hunter LAB value, or you can talk of RGB value, CMYK value. That means I can quantify. But now this color which is shown here is only light source C 1931. Then you say, no, I want daylight. So then you say D 50,000, D 5,000. No, my light source is, because I'm in India, I'm in the south of India, I'm in Kerala and Tamil Nadu. D65 light is totally different than what you see in the United States and Europe. So the D65 in India is different. So you get D65 value, or you can also get D50. So this is how the variation color comes. So this is a very simple example of how we are going to correlate Munsell value, CIE value, LAB value, RGB value, CMYK value with different light sources, daylight, artificial light, full white fluorescent, PL84, etc. And if they are matched, then I am seeing that color is matched. That is exactly what you have to understand. Next slide, please. Now, in Germany, Oswald, he has developed his own color system. It is called Oswald color system. And what he said, that there is a pure color. When I mix the pure color with black, then he get the shades actually, and then he get the tone. So he said that the pure black is on this side, pure white is on this side. So you get the tonal variations, and you will also get the change in the shade value or the tint value. So he has defined the terms pure color, tint and shade. Tint and shade, these are the two things which he has incorporated. And when you are tinting, you are mixing with white. When you are mixing with black, it is shade. And when you are mixing with gray, you are getting tone. So this is how Oswald color system is almost parallel like Munsell. It is very much used in Europe and all other things, etc. And that is also one way of notification of the color systems. And those charts are also available. Oswald color system charts are also available. Next slide, please. Now, if we are talking of computer color matching or instrument, then what we need is, we need an instrument which is having a light source. We need an object which is reflecting the light. So the object, we have to put the object and the light is getting reflected. And reflected light is to be detected by the human observer. So we need a detector. Now, these three things are required in an instrument. What is there in your I1 Pro? There is a light source. You are keeping your object and you are having a detector. Now, light sources are changed, whether it is the artificial light, daylight, cool white fluorescence, etc. So you are having different, whether you are using xenon lamp or whether you are using tungsten halogen lamp. So these are the lamps which you are going to use in instrument. As far as the object is concerned, whether I am using textile material or a paint material or a ink material, whether I am using solid or I am using liquid or I am using film, or if the film is not transparent, then if it is transparent or semi-transparent and fully transparent. So these are the characteristics of object we have to define, and then we have to design an instrument which will be useful for that. And as far as observer means detector is concerned, so early days detector was photo silicon detectors, then photo multipliers were there. Now there are diode detectors available. So solid state detectors are available. Now array of detectors are there. Array of detectors means there are 16 wavelengths, 400, 420, 440, 460. So 16 detectors are sitting in a row. And as soon as light is falling and light is reflecting from the subject, all the 16 wavelengths are automatically detected. So it is instantaneous. Otherwise, you have to scan from 400 to 700. It takes 1 minute or something like. It is not like that. Now, immediately, as soon as you put your object, light is falling on that, and you are now 132 array of detectors are there. That means I can even use zero point 0.2 nanometer, zero point 0.2 nanometer wavelength also I can measure. So if all wavelengths are measured and they all detectors are there in an array of 132, then automatically I can measure. And as soon as it doesn't measure, it is light is measured, it is converted into electrical signal, it is converted into digit, it goes to computer and it computes XYZ value. So that is how the technology has been changing over the years. And this is only a basic thing. Now you may be having any instrument, and in that instrument you have to really find out what is light source, what is the object, what are the detectors, and what is the technology, and how it is converting so fast within no time, so that you can get that one. So I am not going to talk about instruments and other thing, and then you only think of this thing and then find out what are the things which are there. Next slide, please. Now, light source I have quantified, object I have quantified, observer. Now, my sensitivity of observer, as a standard observer, what is my sensitivity for the blue? What is my sensitivity for the green? And what is my sensitivity for the red? If this is determined and reflectance value of the object is calculated, is measured, and the spectral energy of the light source D65 is also measured, then I can quantify color. So the quantification of color is very simple, whether you get RGB or whether you get XYZ. What you are doing is you are looking at this 3 triplet and you are having these modern instruments which are giving you high resolution instruments which are having number of detectors, wavelength gratings are, modern gratings are there, and similarly light sources are also there. Next one. Next slide, please. These are the different light sources, and you can see the one light source is very strong in red, another light source is very strong in the blue light, and another third one is incandescent lamp, which is morning and evening light. So generally what we say that color should be matched in daylight and color should match in the morning and the evening light. If this is matched, then color is generally acceptable. So that is very important. So you have to match the color in morning and the evening light, and you have to match the color in D65, normal daylight at 12 o'clock on the north side of the sky. There you should match the color. So that is a perfect color. And similarly, you have to see in the morning and evening, because that is a different condition. These are the things as far as our conditions are concerned. We India very lucky because we have all those things. In Europe and other places, they have no light source. They don't have light in the morning, evening. Their lighting conditions are changing drastically. They don't have the D65. They don't have A and C like what we see in India. Next slide, please. Illuminants A, B, C, D65, TL84. For example, you go to England, and in England they will say that everything should be matched in TL84. TL84 is their standard light source, where it is a fluorescent light source because it is used in departmental stores. So their technology, they're all matching, and other thing is the basic condition is TL84, which is not our case. In our case, we don't have TL84. Next slide, please. Now, finally, what I am doing, I am putting a object, light is falling on that, light is reflecting, and I am getting the percentage reflectance. Now, this percentage reflectance is determined by the instrument. This is exactly what I am doing as far as color measurement is concerned. Next slide. Next. Now, this is exactly what happened when the light is falling. It is internally scattered, externally reflected. Internally reflected, if it is a thin film, it is passing through that. So all those factors are also to be considered. It is not just a reflection. There are other physics things that are happening. So there is an internal reflectance inside the film. There is external reflectance coming from the top. Then angle of incidence is equal to angle of reflectance. So that is giving me gloss, or that is giving me something which is very important. That is also to be illuminated. So those things, as far as reflection, there are not one type of reflection. There are a number of types of reflection. Multiple reflections are taking place inside, and front reflections are taking place, and angle of incidence and angle of reflectance are, if they are equal 45 degrees, then I am getting a gloss. So some color, even if I have not put anything, it is looking glossy because at a particular angle they look gloss. Even in your, sometimes there are certain ink where those inks are also having gloss because of the medium which they use. So the oil which they use, because of that you get a glossy medium. And as soon as you get, then you get a 3 to 4% change in reflectance value. If there is 3 to 4% change in the reflectance value, it is because of gloss. And if you cannot match the gloss matching is a different problem. That is not related to color problem. You will match the color, but you will not get the effect because the gloss is different. This is exactly what you should understand. Many times when you are seeing your print, the print which is on a opaque paper and print on the glossy paper, you will see that color is looking lighter, color is looking dirty, or color is looking something different because it is some of the oil is getting absorbed by the paper, and that is why you get all these problems. So substrate is very important. You know that substrate plays very important role, and that is exactly, that is all happening because of the paper. Next slide, please. Now this is what I measure color. So I quantified color in terms of reflectance value. So this is a you see, being it is a red, most of the light is reflected, and still there is a little light which is absorbed. When the light reflectance is minimum, absorbance is maximum. This is very important concept we should understand. When there is no light reflection, that means light is getting absorbed. All those wavelengths are absorbed. But here it is not only absorbed, little bit is there in the blue region. That means it is this particular sample of apple, which is bluish in color, mainly because it's the food dyes which are there, natural food dyes which are there. It is having the what is called, it is very simple for me. For me, if the reflectance of A is equal to reflectance of B, the color is match. If reflectance of A is not equal to reflectance of B throughout wavelength, then it is not match. For me, color matching is very simple. You just take the standard and you take the batch and you determine the reflectance value. If they are matching throughout the wavelength, the reflectance is matched, color is matched. Whether it is an ink sample, or whether it is a print sample, or whether it is a paint sample, or whether it is textile sample, this is the first criteria of your matching. Now, in this case, the blue is coming because there is a blue component of dye which is absorbing, and which is, if it would have been red, then in this case it would have been zero there, but it is not zero. This is exactly what you should understand why color is not matching in your printing samples. Because you may be having a substrate which is a bluish component, and that is why this problem is coming out. Next one. Now you can see people are matching butter. No, this butter is not good. Why they are matching butter or tomato or lettuce and all other things, etc. They are all very important. Food technology is very, very important thing in this case. And if butter is not exactly same as that, they have to make 100% matching as far as butter is concerned. It is very difficult, like printing. Next slide, please. These are the different colors. Every color, as I told you, every color has characteristic of reflectance signature. For me, it is very simple. Reflectance of A is equal to reflectance of B throughout the wavelength, color is matched. If there is any deviation, that deviation is because of the pigment dyes, or because of the light source, or because of your eye. So these are the three things you have to decide. Next. Now, I'm not going to detail into physiology and psychology of the eye. Color is a phenomenon of cerebral interpretation in the observer. And color physiology and psychology will tell you that 6 to 8% adult people are blind and 0.5% women are blind, color blind. And one has to really understand the color physiology and psychology aspect of the color, and they will really tell you why people are not in a position to get the matching. And if you have selected a color chemist who himself is color blind and he is deciding the matter, or he is a manager of that, then your industry is in trouble. Next slide. This is the internal retina of the eye. There are rods and cones. Rods are related to white and black. Whatever you see is the white and black is because of rod, and cones are red, green, and blue, and that is why we are at 6. Next one. Next one. So there is a method of determining CIE XYZ value. How we get XYZ value? This is the experiment which was carried out. Here was the light source, and here was the sample which is to be matched. Here was the standard to be actually made by mixing red, green, and blue. These are the light sources. So observers are asked to use this red, green, and blue light so that he can get a perfect matching. So more than 1,000 observers were asked to exactly match, and from that, the CIE actually determined the sensitivity of the red sensitivity of the human eye, green sensitivity of the human eye, and the blue sensitivity of the human eye. This is the first experiment which was carried out in 1931. But why I am showing you this slide is all our color science is basically based on 1931 CIE function. Now that has determined the sensitivity of the standard observer, red, green, and blue. What RGB you are talking is the state which is related to this experiment which was carried out in 1931. That is why I showed this historical slide to you to show you that how the development of color science took place. Next slide. Now, with that experiment, they say that every standard observer is having this blue sensitivity. This is the red sensitivity of the standard observer, and this is the green sensitivity of the standard. So these are quantified in 1931. Next slide, please. Productivity is based on visual trivariance. Next slide. Now that I have already told you that in our eye there are blue, green, and red cones are there, and we are having blue yellow sensitivity, black and white sensitivity, and red and green sensitivity. So these colors are passing from, you are seeing these colors and your brain is receiving these, and then the detection is, it is called benzoid brood effect. You can look into it and you will get an idea of color psychology into that. Next slide. Next slide. I was reading out some of the slides. Next. Now this is the blue sensitivity, green sensitivity, and red sensitivity. Next slide. Now I am looking at the object. What angle I am making? That way is very important. Whether the object is very close or whether it is at 1 meter, that plays very important role. So there are two observers. Standard observers are also two. 1931 2-degree observer. I am making an angle of 2 degree when the object is in front of me, and I am making an angle of 10 degree when the object is put. So this is a very standard observer. We have to standardize observer, we have to standardize illuminant, we have to standardize detector system, and then only we can talk of digital. Otherwise, we cannot talk. Next. 1931 observer, 64 observer. Next. This is how this is 50 centimeter, 50 centimeter. These are the 2-degree observer and 10-degree observer. Next. Now, these are the sensitivity of the 2-degree and 10-degree observer for XYZ values of this one for 2-degree and 10-degree observer. There is slight variation, but we have to accurately feed all these data to computer when we are talking of calculation of XYZ value. Next. Now, this is a simple color science. I will have light source. This is the wavelength, throughout wavelength. These are the light which is falling on my object. This is my sensitivity of blue. This is my sensitivity of green, and this is my sensitivity. So this into reflectance value of the object which I have determined. This into this multiplied by Z value, I get Z. That is the blue component. This into this into multiplied by green value, I get Y component, and this into this I multiply by this, I will get X value. So I from 400 to 700, if I am using 16 wavelength or 31 wavelength or 128 wavelength, because my instrument will depend upon 16 wavelength or 31 wavelength or 120 wavelength, I will get my XYZ values accordingly. So my instrument is having light source. It is measuring the reflectance of the object, and this is the standard detect. These are the functions which I have stored for the standard observer. Now, by multiplying these things, I directly get XYZ. So all your RGB, XYZ, LAB, LCH, FMC, color difference, pass fail, all those things are basically based on this. This is the principle for calculating tri-stimulus value. I think that is very important, which point I wanted to tell you in detail. Next slide, please. Now this is your reflectance of the object. This is the light source, and these are the three sensitivities. So if you multiply by this, you get XYZ value. If XYZ of A is equal to XYZ of B, color is matched. If reflectance of A is equal to reflectance of B, color is matched. Now, if XYZ of A is equal to XYZ of B, but one is in A light source and another is in D65 light source, it will not be matched. But if it is matching, it is isomeric match. It is a perfect match. And that is how the combination will depend upon what light sources you are using and what observer you are using, whether you are using 2-degree observer or 10-degree observer. Next slide, please. Now, this is a complex mathematics. X I want to calculate, then I have to sigma 400 to 700, energy value for 400 to 700, reflectance value 400 to 700, X value 400 to 700, that is delta L difference. Now, this I have to do for X, then I have to do for Y, you have to do. If I give you this, if I give you this data and ask you to do calculation, you will take not less than 2 hours for getting XYZ value. I will give you a best calculator nowadays available. Still, you will take not more than 2 to 3 hours for that. So now you can understand how computer and digital technology is helping you to do that one. Next one. Now the people have come out with the chromaticity diagram. The chromaticity diagram is a definition that I have already got XYZ value, but now I will say X plus Y plus Z is total color. So small x is I am plotting on this one. Small x is equal to X upon X plus YZ, and a small y is Y upon X plus YZ. Then I will get this chromaticity. That means all colors in the world are lying in this chromaticity diagram. That is the definition of the color scientist. Color scientist says that white is here, black, white and black. There is a third dimension which is perpendicular to this. That will give you 0. That will give you white and black. So that will give the different colors. So it becomes 3-dimensional. Otherwise, this is 2-dimensional one. So the pure red is here, pure green is here, pure blue is here, and between yellow and red, between red and green, you get yellow here, and between green and this one, you get this mixture color, and in the center is your light source. So chromaticity diagram means all colors in the world are lying in this chromaticity diagram. Next one. Now, if this is a ball and you want to ask me to define the color, then I will get Munsell value, I will get XYZ value, LFB value, LCH value, XY value, and all those things. That is how I define the color in this one. Next one. Next. Chromatic diagram. So what is the interpretation of this chromatic? Light source is here, white light is here, and this is the pure color. So if your sample is lying here, this is the sample lying. So between this and this is the B value, and between this and this is A value. So A upon A plus B is called purity of the color. That means when I go towards this, I am getting 100%. When I am going towards this, I am not getting the pure color. So the purity of the color depends upon, these are the wavelength, 400 to 700 wavelengths. All wavelength, 100% 700 nanometer is lying here. 540 nanometer is lying here. 560 nanometer is lying here. So 100% wavelength is lying on this one, and this is the purest color. And if your color is not pure, as I told you, your gamut is this. When your gamut is this, that means you are not having any pigment and dyes which will be touching to that one. So the purity of color is defined just by A upon A plus B. So mathematician and physicists always define color in terms of purity. What is the purity? That is, in this case, what is the 100% pure color of 540 is this, but I am not able to get that. I am getting something in between them. Next one. Next. Here, very good example, color. This is my color gamut, and this is the ball. This is the light source, and when I am drawing, this is 680 is the purity of this color as far as this one is color. So that is the purity of the color. The ball is closer to this spectrum color, and that is the pure color. Next one. These are concepts which I am talking. CIE system is independent of human observer. Now we are, as far as Munsell is concerned, we were considering as a visual system. Munsell system is a visual system. CIE system is not looking at an observer. It is independent of observer. When it is independent of observer, it is 100% correct. And that is the difference between other systems and this system. Next one. So all these slides which I am showing, each slide, when I am writing there, that itself is something which you have to think. When you particularly think about that, then you will really know what is the importance and definition of that word. Once you have understood that, then you will understand the problem related to the Munsell color system was in 1905, hue value chroma system, CIE system 1931, that is tri-stimulus system. Then we come out with the dominant wavelength hue, and the value is the Y value of CIE. Chroma is the purity of the color. That is what is very important. Many times you will think that I'm not getting the color because your pigments are not pure. So the purity of the color depends upon the chroma of the pigment. If the chroma of the pigment is not giving 100% purity, you will not get. So your color gamut will be reducing that case. Next.
Excuse me, sir. अजून किती वेळ आहे तसं मुलांना अजून किती स्लाइड्स आहेत?
I think slides are, see, actually one thing I wanted to tell you, I have given you 300 slides, but these are something like 140 slides, but I am not going to cover all that. My idea was I am giving these slides to all students. You can make the copy of that. You understand these slides, you understand your basic color science, which will help you all that. That's all. That is what. And if you want something related to ink, then I will show you 5-10 slides for which there is other. But this is, you can go on continuing. I think you teachers can also help the students. They can make copy of that. You can make all the copies of the slides. You study it, and there are books also. And using the books you can. So I think I will stop here, and I will directly show you which is related practical computer color matching for the ink master. I will show, and digital printing. These two things I will show you. That I will take you 5 minutes and 5 minutes, 10 minutes, and I will close that.
All right. Thank you, sir.
Omkar, just show the ink master. He has to close that one, and he will. After ink master, you show the digital printing, which is your direct subject.
Okay, sir. Ink master.
Yes. These are 5-6 slides. These are the. I have already defined you that you have to define reflectance. Reflectance of A is equal to reflectance of B. Color is matched. XYZ of A is equal to XYZ of B. Color is matched. Or C1, C2, C3. The concentration of the three pigments you have to come out, and you have to determine using Kubel-Kammung theory. Then you have to really get a formulation based on the computer science and algorithm, which is based on Kubel-Kammung theory. So all those things are coming later on. But my idea was that to show you that unless and until you understand the basics and fundamentals of color science, you will not be able to go into other areas. So for me, it is very simple. If reflectance of A is equal to reflectance of B, color is matched. RGB of A is equal to RGB, color is matched. Or XYZ of A is equal to XYZ of B, color is matched. Now this is exactly what we do in computer color matching for paint or also textile or ink. Now in case of ink, you are having this modern instrument, I1 Pro, most of you have seen that one. This is the Minolta spectrophotometer, which itself is directly giving you all the information on the screen, and you can connect it to the computer. And I1 Pro, though there is not much information, it is directly connected to the PC or laptop, and you can able to get XYZ, LAB, RGB, and reflectance value, etc. So these are the modern spectrophotometers, which are very handy. They are less than $1,000. Now this is what in Ink Master. Ink Master, you are having all the inks. You have to store the data of the inks. These are the different inks. So cyan, then orange, and rhodamine, and rubine, and you have to store the data with different concentration. You have to store the data for particular particular ink system. What is the ink you are using? That ink system. Then you have to also store the data of your substrates. What substrate on which you are going to print. So these are the two things which are required. Next one. Now, once you have done this one, then it will give you what is the standard. Standard is yellow and the batch is red. Now, if the reflector score is matched, color is matched. Now, if this is exactly what you want to do, then for getting this one, computer will measure standard, computer will measure batch, and computer will select the pigments which you have stored, and it will give you combination that I am using extender. In this case, 000 is there is no extender. Then I am using cyan blue, rhodamine, and opaque. So you can see how much very small quantity of cyan blue and rhodamine and opaque white is giving me this particular shade. Then it will give you its LAB value, LCH value, delta H value, delta E. Color difference. What is the color difference? It is saying that I am able to get very close match. As far as L is concerned, it is 0.16 and 0.68, and B is equal to, it's slightly, the blue is very high in this case, and chroma value. Now, if whatever small variations you are seeing, that you can see the curve is here, it is overlapping, it is going above, it is coming down. That means I am not using the same pigments which are there in the original. That means whatever inks which you are having, you are not having exactly same ink. So you have to live with this one. This is the best possible color matching you can get. That is why it is said that this is fail, because in your case, this is metameric. Since it is not matching in when the reflectors of A is equal to reflectors of B, it is not perfectly matched. It is not matching. Since it is not matching, the color is not acceptable. This is what your color matching system will give. And this diagram will tell you that now this is redder, this is greener, this is yellower, this is bluer. So this one is bluer. Now this is bluer and this is darker because it is below. So it is bluer, it is darker, reflectance is not matching, and this is how you are failed in this particular combination. Next one. Now you say, okay, I am having these calibration dyes. These are the different inks which I am having. And you, as an industrial application, you have to give all this information. What is the cost? What is minimum concentration to be used? Maximum concentration used? What is the strength of ink? Today I have got the ink which is 80% or 90%. Now last time when they have supplied it is the 85%. Then naturally the formula will not be the same. So the strength you have to give. You have to give the concentration, you have to give the solvent. If you are changing the solvent, then you will have all these problems. So in the production batch correction or production matching, you are going to have all these variables which are related to color. Next slide, please. Now here you can see, this is how you will, this is called calibration of data. This is your basic ink, and these are the, this is a blue color, and this is the 1%, 2%, 3%, 5%. This is how it will. And actually, in this case, it is 1, 6, 12, 25, and 75% of the color. And then you have to also define what is its refractive index. Then only it will be able to find out. So these are all parameters which are to be considered. Next one. This is the another one. Now you can see that whether your concentration, as concentration increases, whether the absorbance value of your color is changing or not. It should be linear, and in this case it is linear up to this. After that it is not that linear. So all these factors are also to be considered. Next one. Now this is another example. This is the one which I am likely to match. Next one. Now I have selected this particular substrate. I have selected these whatever I want to select the pigments. The one which is selected, it is going on this side. And once this is selected, I will be able. Sometimes you want to use the waste. There are waste ink also. So I can make using the waste ink or using the black also I can make the matching. So that is also very important. In this case, the waste ink which are already combination of 3, that will give you close matching sometimes if you want to consume the waste ink. Next slide, please. Next slide. Now here, previous one, here. Now this is the standard value. It is a fairly good match except in these 400, except in 600, 8 to 700. And these are the combination extender, rhodamine, rubine, and yellow. Now here you can see matching delta E value is 0, metamerism index is this, full white fluorescence and percentage this one, and cost also it is giving. So these are the things which you can do. That is very important as far as computer color matching is concerned. And I can get a fairly good match in this case where the color difference is, you can see that in daylight it is very good match, but in case of third light source, now I don't know what is the third light source, which was there in an earlier slide. The third light source, it is a 0.5. So maybe in this particular light source or 0.67, it may not be acceptable because it is a metameric. It is a illumination. Metamerism is playing very important role. So in different lighting condition, it may not match. Otherwise, as far as daylight is concerned, it is matching. Next. So this is how I get a combination, and this is this one, and I can get the total one. This is the printout of that. Next one. Now I can get LAB plot, and LAB I can quantify what is L value difference, A value difference, B value difference, what is reflectance difference, and what are the pigment. Here is very important. Now modern mathematics, modern programs say that I can adjust L value. I want lighter darker only adjustment. For this color, I want lighter darker, or I want red green adjustment, or I want yellow blue adjustment. So I want only little darker or little lighter, or I want little bluer, or I want chroma. It is not saturated. I want this saturated color. So the chroma is there, the hue is there. That means you are able to play with this type of software. This software, here you are just, how you are playing, because you are saying that yes, fix L value, fix lighter darker value, fix chroma value, fix hue value, fix value, hue value. So you can really do the wonders with this type of technology software. Next one. And then you are, in this case also it is said that it failed mainly because it is not matching in two lighting conditions. That is why it is said fail. So pass and fail depends upon how you play with this instrument and get better and better match, or maybe you don't have good combination of different pigments available in your grid. Next one. Next. I think now we go to another one. I can go on telling the various things, but basically the idea was now last one you can show. There are 4-5 slides. That is very important for you as a printing technologist. Now, digital printing. I'm just throwing some light. These are the things very important. All methods of printing images on paper have this in common. They all render color through subtractive color mixing. That is very important. Which you may be knowing, but this is the very important thing. That is why you face problem. Next one. Many digital color printers use only 3 colors, cyan, magenta, yellow. A 3-color process produces a very good quality images depending on the nature of the color. If you don't have proper CMY inks, you will not able to achieve whatever colors you want in your gamut. That is what I wanted to tell you. The 3-color process is a very, very critical, because you have to select very good C and M and Y from the ink manufacturer. If they are having any variation, you have problems. Next one. Now, printing inks. Inks used for printing presses are by nature somewhat impure. You have to determine the strength of that. You have to do strict quality control of XYZ value, delta E value, and strength value. If you do not do correct quality control of these 3 printing ink, you are going to face n number of problems in your production. Ink used for printing presses are by nature somewhat impure. They are not perfect filters. They absorb some light that should be transmitted. So if you are facing any problem in your production, why you are facing problem, you look at the strength value, you look at the absorbance value, you look at the reflectance value, and that will solve your problem. That is why I am showing you this slide. Next. Core printing color process CMYK and K is a black. Deficient of printing inks have led to 4 color process that include black ink. It makes shadow. The black is not black. The black ink which you are getting, some people are getting black ink which is redder. Some people are getting black ink which is greener. And that is going to create you hell of a problem with CMY matching. So deficiency of printing ink led to a 4 color process that include black ink. It takes shadows appear denser and improves overall image contrast. Substituting black for overprints of 3 color reduce ink usage. It reduces ink cost and it makes the process easier to control. These are just simple guidelines, those who are using CMYK and black. Next. Color gamut, which I was talking about. When I am talking of a addition of light, I am having this color gamut. When I am talking of monitor, I am having this color gamut. When I am good printer, this is my color gamut. And I am in a press, this is my color gamut. So color gamut goes on changing. So you don't expect anything from press and the printer same, because they are different actually. Good quality printer, what I mean that. And the press will not have the same color gamut as this one. And don't expect that what you see on the screen or TV or on monitor, you will get the same thing on that. And similarly, what you get in the film is like this, and what color gamut you get actually by addition of light is this. So that is what I wanted to tell you. Gamuts must be compressed to some degree during reproduction. Next one. Now, the paper plays very important role. I don't have to tell you, because you must be really doing a hell of a job when you are not able to get high gloss and uncoated paper. Naturally, high gloss you will get a very bright color, and in uncoated off-white you will get a very dull color. Actually, your color may be matching, but you are getting, because light is being absorbed, and then you are not getting the glossy effect of that, and that is why your reflection value. This is because of the 3 to 4% change in the reflectance value from this paper to this paper. Next. Now these are color and inks and toners and thermal waxes and thermal dyes. Each one is very important when I am determining the strength of that. If the strengths are not same, then you are going to face problem. Then toners variations of these are also very important. Now inkjet printers from dots by spraying color inks from a matrix of tiny jets controlled by digital signal. So this technology is slightly different, but these things will make a difference when you are having this technology or this technology. Color laser printers are similar to color copiers. They use color toners, a photosensitive drum receive. So as soon as the new parameters are added, the new technological differences are there, and color science changes because of the technology which is here. Next one. So this you are familiar, thermal printing. That is another area, and there are so many other parameters which are affecting. Thermal wax printer. Then after each color is transferred in a thermal printer, the receiver is automatically repositioned for the next trace, and proper registration of each pass is a critical. So these are variables. Unless and until you make variable constant, you will not get good color matching. So what you have to do is make all variables constant. If you are making all variable constant, then only you will get a perfect match. Next. I think this is a thermal dye transfer printer, then pole color process printer, dots of cyan, magenta, yellow, black printer, then screen half-tone printer. Next one. I think I have finished this one. Half-tone dot, I think you know about that. Half-tone dot produce full color images when printed with ink called processing. Dot varies in size with small dot. That means you have to make process variables as a constant. Now, what is variable here is dot vary in size. So that is a process variable. If that process variable is not constant, you are going to get a mismatch. Next one. After color images are edited and image setter processes the image information and record dot values on film to create the separation. This is the technique which you use. Next one. 150 lines or 200 lines or 300, 100 lines, or that is half tone very important in this case. So it is a process variable. The process variable create a problem for your matching. Next. Image setters produce a page size or larger fields. So that is why there are variation. People go on trying actually. This eliminates the hand assembly. Color proofs are needed to check the image after separation and screening. Overlay proofs carry 4 colors on clear sheets and combining them for full color image. That you know this particular technology. Then you say, okay, it is pass or it is fail. Your pass fail depends upon this one. Next. Single sheet laminated proofs are more common. They provide close representation of what the final print will look like. Next. Now these are different things, some proofing systems and all other things, etc. Next. Today, color pages can be printed cost effectively in quantities of hundreds. Next.
Slides are finished, sir.
I think that is what I wanted to say. I hope I have tried to cover, but basically I have tried to tell you more about the basic fundamentals. I will tell you that if XYZ of A is equal to XYZ of B color is matched, reflectance of A is equal to reflectance of B color is matched, and you can get the combination, but you have to keep the process variable constant. If the process variables are constant, then you are free to ask questions. But one thing I wanted to ask you, you have to find some solutions for the questions which I have raised while showing you the slides. So that will be your real exercise. Okay.
Yes, sir. Thank you, sir, for your beautiful explanation on color science. Now, I would like to call Mr. Professor Mahajan, Abhinay Mahajan.
One second, Omkar, there are some students have given question in chat box, so you better answer, try to answer. Yeah.
Sir, Prathamesh is asking a question. Sir, which one is more sensitive, red, green, or blue?
No, they are all equal. Red, green, blue, it is no sensitivity. Sensitivity, you have already seen the curve. The red sensitivity curve is different, green sensitivity curve is different, blue sensitivity curve is different, because in our eye there are 3 cones. Not one cone it is. There are millions of cones. Total number of cones are 2.5 lakhs or something like that. So our red sensitivity, our green sensitivity and blue sensitivity depends upon each human being and what is the structure of his eye. So we have determined for the standard observer, after selecting after selecting 1,000 observers, International Committee on Illumination have determined the blue sensitivity of the human observer, green sensitivity of the human observer, and red sensitivity of human. That is a standard. If my sensitivity is different from that, then I am color deficient. I hope I answered your question.
So the next question is from Shubham Naikere, BE Printing. While taking measurements, if reflectance is more than 1, then which value to consider? As we get reflectance below 1, and in I1 Pro, we get between 0 to 100.
0 to
100.
0 to reflectors cannot go more than 100. If reflectors is going more than 100, it is not the pure reflectors. It is a fluorescence which is adding to that one. And reflectors 1 or 0 is nothing but black. It is 0. That means it is almost as a black. That is the difference. So 0 to 1, or see, instruments depend. They say that 0 to 1 or 0 to 100. 0 to 100 means 100% reflectors means all light is reflected. 0% reflectors means all light is absorbed. So 0 to 100 or 0 to 1, these are the scale which instrument you are using, that they will tell you. So 100% means all wavelengths are equally reflected. All wavelengths are 100%. Generally, no wavelength is 100%. No color is 100% reflected. It will be having less reflectors in the blue region, and then it will be 85-90% in other wavelength. And as far as black is concerned, as I mentioned you, the black is no black. Black is having blue component or red component, so you will be having 2 to 3% reflectance of the black actually. maximum reflectance of black is 3% or 2%. So if it is throughout wavelength, it is 2 to 3%, then that is black. And if throughout 60 to 70%, it is white. That is the general observation of that.
The next question is from Abhishek Zirwankar from BE Printing.
Yes.
Same, but LAB is different.
LAB?
Is it possible that reflectance value is same, but LAB is different?
No. See, from LAB value, from where you are calculating LAB. LAB value you are calculating from reflector. From reflectance you are calculating XYZ. From XYZ you are calculating LAB. Now, how it is developed, that is what exactly earlier I have told you, but maybe I have not shown you some of the slide. From reflectance value, we get XYZ value. X is red, green, yellow, blue, light, dark. Now, that is not understood people properly. So, people talk of LAB. L is a function of Y. A and B are function of X and Z. So that is how LABs are calculated. LAB is calculation from LAB or LCH is calculation from reflectance only. So if reflectance is not matched, LAB will not be matched.
But sir, is it possible like two people are viewing the same color in under same light light like D50? Still, both of them will see the different color, even if their reflectance is same, LAB is same,
That
but
is
both of them are.
Yeah. Correct. In that case, it is because of his sensitivity. His eye is different sensitivity. So there are tests which are to be carried out. Anybody who is in the color business, he has to pass the test. And if he is not color blind, actually it is not color blind. People don't immediately become color blind, but less sensitive. They become less sensitive for yellow or blue. So, for example, by age, some 20 years back, if you are asking my sensitivity, it was different, and now it is different. So sensitivity becomes upon the age also. Over the year also it changes. But we have to have standard observers. Those who are doing quality control, they should pass the test.
Right.
Ishara test also. There are so many tests which are there. So if they have passed the test, then they are authorized to do that. This is the first basic thing. So if they are authorized, if there is such a dispute, generally in our paint industry and in textile industry, we are appointing the quality control chemist who has passed the test. If he has not passed the test, we don't accept his visual observation.
Right.
We don't. In ink industry also, in printing ink also, those who have, but there are some people over the year, their deficiency changes, and so they will contribute that one. So that is possible.
Right.
And there one more thing, in every quality control lab, there is a light source, standard light source.
Yes.
Light booth is there. So that light booth is daylight, artificial light, cool white fluorescent, TL84. So if you are supplying to any particular country, you have to go to the light booth and say in a light booth, this is passed. In artificial light booth, it is not passing. In D65, it is pale or something like that. That is what it is. So that is as far as light booth is concerned. As far as observer is concerned, he is tested.
He is tested, correct.
As far as instrument is concerned, if there is a malfunctioning of the instrument, you have to get that instrument is properly working or not.
Yeah, okay. So standardization.
That is also very important, because if my XYZ value doesn't match with your XYZ value, I am transferring my XYZ value to you. So between your laboratory and my laboratory, we have to have standardization, and we will say that my XYZ, you will not argue for my XYZ value or LEB value.
Right.
Unless and until that one happens. Otherwise, both of us have to use the same instrument, and we have to standardize how you are looking at it, how you are measuring. I am also doing same thing. So you are giving me certain instruction that while measuring you do all those things, and I will. Suppose now in case of light is passing through the ink paper, so below is some another substrate. So the natural reflectance value change, LEB value or the delta value will be changing. So I have to white tile below, and what white tile I am keeping? If I am keeping some white tile which is different than yours, naturally maybe that another person who has asked me that LEB value is different, so he must be putting some black below. It was with some black below. So that is also possible.
Sir,
Omkar, next question, please.
yeah, the next question is from Atharva Kulkarni. He is asking how exactly Munsell color conversion works.
Munsell?
Color conversion works.
Munsell, there is no Munsell color conversion. Munsell color conversion is a visual system. And what Munsell has given is that, okay, the Munsell color atlas is available. So he has collected thousands of colors, organized them in order, and then he has reproduced those atlas which are available in the market. So if I say I want this particular blue, so I will say 1.5 blue value is equal to 2.8 and chroma is equal to 3.9. So these values I will be sending you from India. I am sending it to Germany. So Germany, he is having Munsell book color. So he is also using this. He is also thinking of same color. So as a ink, he is exactly making your Munsell color. So Munsell color is a specification you are expressing and giving to anybody. So that will help you. You need not send standard. You say Munsell color. This is the Munsell color. You are having Munsell color atlas and you are matching that color. That is the meaning of that.
Okay. The next question is from Akshay Ingre. He is asking why are the observation angles 2 or 10 degree and why not other angles?
No, see what happened. I am a quality control officer. So when I am looking at the object, I am making certain angle with the object, standard and the badge, because I am looking both at standard and the badge. So you cannot keep 1 meter away or 10 meter away. So I am having in my hand. So I am making not more than 2 feet distance between them. So the 2 degree and 10 degree determine how much angle I am making that one. So 2 degree angle is a very small. I am looking like this. That is not correct actually. So you have to have 10 degree. So earlier in 1931 it was 2 degree. In 1964 they have come out with 10 degree, and now almost everybody is using 10 degrees. So 2 degree is now obsolete.
Okay. And Prathamesh is asking when to use 2 degree and 10 degree angle. Okay. You have to
Always use 10 degree now. Always use 10 degree. Always use 10 degree.
Akshay is again asking, what do you mean by tri-stimulus value?
Tri-stimulus values, that is exactly what I have explained to you. X, Y, Z value. Every color is now reduced. Using light source, I have a energy spectrum. I have a reflector spectrum of the object, and I have color matching function X bar, Y bar, Z bar. So when I am multiplying energy multiplied by the reflectors multiplied by X, X is red green sensitivity. So what X value I is my eye is having 3 stimulus, red, green, blue. So the X, Y, Z number is related to my eye, and that is stimulus. These 3 stimulus. So instead of reflectors value, reflectors multiplied by energy multiplied by X gives me X value. Then multiplied by Y gives me Y value, and multiplied by Z gives me Z value. X, Y, Z are 3 stimulus values. And these 3 stimulus values are related my standard observer. In this case, X, Y, Z of light source A is equal to X, Y, Z of light source B. Then the color is matched.
Okay. The next question is from Vijay Zadav. He is asking how the gamut compression and expansion is carried out.
Gamut expansion depends upon new development in the ink pigments and new development in case of dyes and all other things, etc. Unless and until you don't have the new pigments, new inks, you will not able to increase the gamut of that one. So the purity of the gamut will go on increasing depending upon the new technology. See, every day hundreds of organic pigments and dyes are researched actually. So that is what the pigment and dye stuff people are doing. So all new dye stuff and pigment companies, they are always giving you new yellow, blue and red, and that is why the gamut is increasing. So you don't have to even, then in that case you have to find out who is the pigment manufacturer giving me better red, green and blue. So you have to change your ink based on those pigments.
Okay. Thank you, sir. Now I would like Professor. No, there is one more question from Shubham Naikre. Which spectrometer mode, that is M0, M1, is suitable for measuring textile?
Measuring?
Textile. Which
Textile.
spectrum?
Oh, there are number of instruments which are available, and there are different manufacturer. X-Rite is there, Data Color is
No,
there.
is asking in which mode is used. That is in spectrum photometer, which mode is used? M0 or M1? Which is suitable?
No, but I don't exactly know M0 or M1, but what I am trying to tell you is that unless and until I see the specification of your M0 and M1, because every second year the new instrument is launched. Every second year new instrument is launched. So we have to see the specification of instrument, and there are different criteria. So I have written 2 books which you have already shown there, Science and Technology of Color. I am going to give the 5 copies to madam.
Okay, thank you.
For the library and also for students and staff member. So there you will see what are the criteria of the different instrument. So I'm not pleading for any instrument manufacturer. I'm giving you look at these characteristics of these instrument. If these characteristics are met, then you are having better instrument.
Sir, there is a mode called, M1 mode, which is recently introduced. It is for the optical brightness agent calculation. So
Then it is fluorescent one. So it is having the fluorescent one. So the xenon lamp, which is having unless and until it is having UV component, UV included and UV excluded. So generally, UV component included instruments are for fluorescent brightening agent. So when the reflectance is going more than 100, it is FBI, fluorescent brightening agent, FBA, fluorescent brightening agent. So those instruments are used, but in normal reflectance spectroscopy, we don't need fluorescent brightening agent. So we generally measure below 100. But there are some instruments which will give 300%, 400% reflectance value. So, what it is doing in that xenon lamp, the UV component is very strong by using certain chemical compound. So naturally, it increases the intensity. So the fluorescent brightening, if you are doing fluorescent brightening agent, naturally you should use that type of instrument, M1, what you talk about. But normal instrument will not have that one. But generally, what happens nowadays, they include it. But normal color matching, you get below 100, and in case of FBA, you will get it is more than 100.
Yeah. So he is asking, if I'm measuring on textile, will I have to have that UV reflectance wala mode? M0 is enough.
Yes, they will. It will add cost to that one. I'm not doing most of the time FBA. Those who are using FBA common, because in that case you have to select the instrument which is having UV component in. So I have not talked about that one, but UV component in and UV component out.
Right.
Then you will able to determine what is the intensity which I am getting, whether it is this fluorescent brightening ink is good or this fluorescent brightening ink is good. That also you can.
Right. Okay. Thank you.
Thank you, sir. Now I would request Professor Abhinay Mahajan to share his feedback on the webinar. Over to you, sir.
Hello, everyone.
First of all, I must thank all of you, and it is very nice that all of you have really helped me to make presentation, and madam has given me chance to present to your institute. Thank you very much.
Hello. Yeah. First of all, I would like to thank Dr. Gangakhedkar for making this beautiful and nice presentation, and the organizers and organizer staff and the students to call on all eminent speakers this week to make the Color Week a great success. So thing is that student can get a very wide gamut exposure on color as a subject. So Dr. Narendra Gangakhedkar is a stalwart in the color industry. He has searched every aspect of a subject. He explain what is color, uh, basically vision mechanism or the capturing mechanism, object and a light. So what is the spectral distribution of that particular light illuminant, what is the reflections of object, and what is the response or stimuli we can able to measure with the capacity of instrument that can record the color, right? So, whereas almost every aspect of a subject, uh, he tells what is color, what is the standard illuminant, what is standard observer conditions, what is the difference between 2 degree and 10 degree observer, how do we perceive color, what is the metamerism, how measurement makes sense, if we excluding or including UV component or fluorescent component, he even touched to the digital printing. Why do we require CMYK? He touched to a different color space systems like Munsell and Ostwald and even the modern color management system. He explained the observer angles and their difference, that smaller window and the larger window, and there is a subtle change in the response and why to choose on 10 degree observer angle. So, whereas the very well touched every aspect of a subject, he tried to give whatever possible to the student and to the faculty to get a wide exposure of a subject. I really appreciate that sir has wholeheartedly uh, just wanted to give everything what he knows, and it is very much possible that with more and more interaction with sir, we can very well develop our knowledge base, and it's really appreciable to organize such a great event. I thank you to the management as well as to the organizer and students for coming in a number and joining and getting a very well exposure of the subject. Thank you, sir. Thank you very much.
Thank you. Actually, I have taken more time. Sorry for you. You have to spend more time for hearing me.
Yes, sir. We will welcome more number of interactions so we can get more from you.
Thank
I
you.
really thank you.
Thank you,
on behalf
Mahajan.
of department and college.
Yes, thank you, sir. Thank you, Mahajan, sir, for your valuable feedback. Now, I request Akshay Joshi, sir, to share his views on the webinar.
Okay.
Over to you, Joshi, sir.
Okay.
Is he there? Joshi sir?
Joshi, sir is there, I think.
Okay. I think we'll just wrap up because it's already nearing to 6. So, yeah. So before we conclude, sir, like I will share all the 6 days details with you. So please feel free to join the next sessions if you have time.
Sure, sure.
And it is all 4 to 5 every day for till 17. So Omkar will share you the posters, and if you have time, you are more than welcome to join us.
Thank you. I will certainly try to attend.
Yes, yes, yes. Omkar, over to you.
Yes, now I would like Omkar Kulkarni to give the vote of thanks.
Good evening, everyone. Thank you, sir, for your valuable time and efforts towards our student. Your valuable knowledge and depth explanation will surely help us. Thank you, our teacher and staff members, for supporting us. I would like to thank our hardworking team, Akshay Ingre, Onkar Kokate, and me, Ruket Upadhyay, Aditya Uge, Pranali Kataria, Shubhangi Chavan, Vijay Jadhav, and Riya Pallade. And I would like to thank SCT and B students for making this webinar for more interactive. I also like to thank you our today's moderator Onkar Kokate. He handled today's session very well, and thank you to him for running it smoothly. Now I over to you, Onkar.
Thank you. So I conclude today's session as over. Thank you, sir, for your valuable time and your beautiful introduction and speech on today's topic, fundamentals of colors. And I hope everyone has gained a lot of knowledge from this session. And I hope we would have many interactions with you in future. Thank you, sir.
Thank you, Omkar, for your
Thank you.
coordination.
Yes.
Thank you, sir.
Thank you, sir.
So,
Good evening. And I'll make sure that Omkar share your PPTs with everyone,
Okay.
yes, sir.
with all SCTB students.
So today and one more announcement. So please fill the feedback form given to you in the chat. And today at 7:30 p.m. we'll be having a quiz. So please be ready for the quiz. Thank you.
Yeah. Shubham, sir, you can stop the recording now.
Okay, ma'am. Yes.
Yeah.